All right, so tonight we're going to talk about HTTP. We briefly discussed it on Tuesday and talking about the different tools you can utilize to make HTTP requests to either APIs or various websites, as well as the responses you get back. But let's actually talk about HTTP and a little bit of the history of it and like what is included in an HTTP request and response. And we kind of briefly discussed this previously, but we're going to go in a little bit more depth, but not super in depth, talking about like TCP and IP addresses. We're not going to talk about that. We're just going to talk about HTTP. Can anybody tell me what HTTP stands for?
Hypertext Transfer Protocol.
Awesome. Yep. Good job. Just stands for Hypertext Transfer Protocol. And it's essentially how information is sent and received over the web. It's just, it's just the specific rules of how the entire web is connected and how it communicates with one another. So it stands for Hypertext Transfer Protocol. It was originally described in 1991 with the origins of hypertext, but it actually dates back, all the way to the 1930s. So before we were sending HTML, we were sending hypertext, but nowadays we can send all kinds of stuff. So Hypertext Protocol was originally designed as a protocol for transmitting hypertext. It's equivalent to HTML now, so everyone should be very familiar with HTML. But back in the day, you would just link to page, like literally one HTML page to another HTML page. But now HTTP can send all kinds of files across the internet, such as CSS, cascading style sheets, JavaScript, video, like video data, images, all kinds of data is sent through HTTP. Think of Netflix streaming video or YouTube. So you can send all kinds of information using the HTTP protocol or HTTP. Any questions on that? So it's evolved substantially over the past 30 years. All right. So with HTTP, there has to be, it's essentially a conversation between two parties. There's the client, which is you making a request in the web browser. So if you go to www.google.com, you are the client. They refer to the client as like the actual browser. And the other party you're speaking to is the server. It's some server, whether it's Google servers or just some server somewhere. So the client will make a request to the server and the server will respond back, or typically in plain text. So it's super easy to actually read from a human standpoint, as you saw yesterday when we had like the request line where it says get /HTTP/1.1. It's very easily human readable. So it's literally just plain text that you can read. And also like you can actually write these requests and responses in code, like literally just create a string with the specific parameters that the request requires in order to successfully make a request. So if you think about, like, if I go into the DMV or somewhere such as like a car dealership and say, yeah, I'd like to order some food, they'd be like, we don't know what you're talking about. This is not the location to do that at. Or if you go to the DMV and try to order, a Big Mac, they're gonna be like, you are in the wrong location. So it's going to give a response back. So regardless of whether your request is good or not, it's always going to give a response back. Whether that response is a 200, like, okay, a 404 not found, or a 500, like, you can't comprehend what you're actually requesting for. All right. So let's actually talk about the request and response. that is required. So this should kind of look familiar from Tuesday. So if I had to make a request, I need to have, again, this is just plain text. Up here is the request line, which is the first line of the request. And there's three things you need. The get, which is the type of request, the locator where you want to make the request to on the server. So it's like /bio.html, as well as the HTTP protocol version. So HTTP version 1.1. And then over here, you also have, well, yeah. So let's talk about the request line. So we have the method, which is the get. So what type of method? We're doing a get request to the URI, uniform resource identifier. This is also like where in the server you want to grab the information from. So that's the URI, not the URL, uniform resource identifier, and the protocol version. So again, this is just plain text. So get space, whatever, the URI space protocol version. So there's a bunch of different types of requests, but the main ones are get requests. Again, just should be reviewed, is to retrieve a resource from the server. Post is to send a resource, but generally also to create a record within some database. Put is to update a resource in a database. Delete is to delete a resource in a database. What questions do you have about the different HTTP requests? All right. So we kind of talked about this. The URI is literally just everything that comes after the last / of the host. So if you want to know what URI is, again, we have get, bio, so the request line. So you have the URI, URN, and URL. So the URN is uniform resource. Does anybody know what the N stands for off the top of head? Uniform resource name. That's what it stands for. And then we also have the URL. So when you talk about a URL, it includes the protocol, the host, and the URI. So there's three different: URI, URN, and URL. Again, URI, the host, and then all three of those, the protocol version, followed by the host, and the URI consists of the URL. So after we have the request line, so we have the request line, and then again, all in plain text. On the next lines, plural, there can be multiple. We have the host. It's called the headers. So after the request line, we have the headers, and the headers can consist of multiple different attributes or information, such as the host, like where are we going, google.com, example.com, as well as the user agent. So where am I making this request from like a browser standpoint, typically? So example, Google Chrome 552.34. And just why would the server want to know the user agent?
Different agents or browsers act differently.
So, yep. So different user agents or different browsers act differently. But okay, so if I know a specific browser operates or acts in a different way, what as a server, what can I do?
You'd be able to pull up different parts of the code. Like if you know Chrome doesn't support who knows what, a certain version of Adobe or something like that, then you would not send that to them if you wanted your page to display correctly.
Yep. Yeah, exactly.
Correctly.
Yeah, exactly. So depending on a user agent, as the server, if someone sends me this request with the user agent of Google Chrome 52.34, I can be like, I can read that from the headers and be like, you know what? My app doesn't support Google Chrome 52.34. My app only supports Google Chrome 63 and higher. So I can send a different response back depending on the different user agents, whether it's
I think a really good example I could think of is if you hit it from your phone, it's going to have a completely different browser version, and you'll know, oh, that's going to be a different display that we have to send.
Yep, exactly. So I can send different assets back depending on whether it's on your phone or anything. In fact, the first company I worked at, like no one supports, well, I don't say no one supports, but like there were people visiting our application that were on Windows Explorer, like no internet. Yeah. What's the old one? Internet Explorer.
Yeah.
IE.
Some like Navigator.
No, it's not that. No one was actually visiting us via Netscape Navigator. But like people were visiting us from like Internet Explorer, like super, super old. And our application wasn't compatible with certain Internet Explorer capabilities. So we literally send them like a message to like a different web page saying like, hey, if you continue using our application on Internet Explorer, the product's going to be not that delightful. Please download these versions to make it a delightful experience type of thing. So we'd explicitly send different information, different web pages back depending on the user agent. All right. So with these, again, this is a GET request. We can send multiple things in the headers, host, user agent, a bunch of different content type. Actually, I don't know if content type is, I think that gets sent back, but there's a bunch of different items you can send in the headers. And now let's talk about a post request. So with a post request, so I go to like example.com/search. So I could send the content type. So application, whatever. Don't even know what that actually means. So in the request, I've got the request line. The next lines, I have the headers, and then I have a space, like literally a line break. And then I have the body, and the body is optional. It's not required. However, if I want to send data or some sort of data to the server using a post request, you typically send it in the body. So you can only send data in the body using a post request, a put request, and a delete request. A GET request, you can't send items through the body. So if you want to send data to the server, in the body, you have to use a post, put, or delete request, or patch too. GET requests, you can only send data in the URI essentially. So for example, I'm doing a GET request and I'm doing a search query. I'm sending that search query in the URI up in essentially the URL where you would see that. So additional request data can be included as part of the URI instead of being included in the request body, but that's only for GET requests. So if you're going to send data to the server that the server needs to process some information, typically when you send it via GET request, you will send it in the URL or URI. And when you're sending data over using a GET request in the query params, so anything after the question mark is a parameter that the browser or the server can parse through. So query params are separated from the URI with a question mark. So we have search, question mark, and then whatever parameters, query equals Air Jordans colored red, HTTP 1.1. And you can see that if I open up, if I go to like Amazon, And like, what is something somebody has searched for on Amazon or wants? Like headphones or patio furniture. My wife and I have to buy patio furniture for the spring. So you look up here, we have Amazon. S probably stands for search, and then question mark. Everything after this is a query param. So K, I don't know what that equals, patio plus furnish plus set, and I don't know what CRID equals. So Amazon is parsing through this and saying, hey, this person searched for patio furniture set, CRID. This is, I don't know, some ID that might be referencing me as a user, maybe the browser, and some other information. So if I ever do a GET request to this URL, it'll take me directly to that page. So if I click enter, it's a GET request. It reads from the URL, specifically the URI portion, and it parses through that query and brings me directly, essentially searches based off of these query parameters. Any questions on GET requests and sending data to the server? All right. So request headers provide additional context about the request. Again, we have the host, some examples, the accepted language, English. So maybe if I was, in Spain and my browser looks at my latitude and longitude, or I've got my browser set to Spanish, it'll set accept language Spanish. So when it gets to the server knows I would like a Spanish language being sent back. Same with user agent, what I'm accepting, what I'm willing to accept back as a response, text, HTML, text, plain text, JSON, whatever, or I can just say like accept everything that comes back. All right. So we have the request. Now we have the response. So the response, we have the status line is the first line. So it's the HTTP protocol followed by the status code of what's the status of the response. Is it a good response, bad response, or I'm sorry, bad request? There's 200, okay, which is good. 300 typically redirects. 400s not found. 500s there's some internal server thing that the server can't even process a response. So we have the status line. Then we also have the headers on the next lines. So like content length and bytes, the date, content type that's being sent back, text, HTML. There could be a bunch of different headers, not just these three. And then there's a blank line. Again, this is all in plain text. You can write this down in a string. And then in the blank line, whatever comes after the blank line is the body, which is typically what is sent back. So if it's typically HTML, it could be pretty much anything you want, but it is optional. But when I make a request to that Amazon.com, where'd it go? Right here, if I kill that, whoop. And I open up the network and I click that very first one, I can look at the headers. So I do a GET request, status 200. This is the request URL. It's a GET request. The request headers that it was sent over, authority, method, path, scheme, accept, what I'm willing to accept. All this stuff is being sent over. And then in the response, what Amazon is sending back are all these response headers, content encoding, gzip, don't know what that means, date, content type, all this stuff. So that's what's in the response headers. And then in the body of the response, if I look over here, you can say right here, if I click that, this is what the body of the response looks like. All this HTML. So it's over 15,000 or 14,000 lines. And you can preview it like so. But yeah, so that's what's actually being sent back as the response. Yeah. So that's what would be right here in the response. Any questions on that? So we can talk about the response line up here. Very similar. We have the status code 200, OK, HTTP version, like so. Again, status codes, we went through. 200s are OK, 300s are redirects, 400s are generally bad requests, unauthorized or not found, and 500 are something in this server totally broke and it wasn't able to actually send a response back, or it does send a response back, but the response is a 500. So something internally wrong is with the server. So again, response headers, there could be a bunch of stuff. Content type, what is actually being sent back, text, HTML, JSON, content length, how many bytes is how long is the response. It can also send cookies back. So we can send cookies in the headers to be saved in the browser. So if you visit that again, that browser, that host again, it knows who you are, as well as date. There's a bunch of other stuff. So for each request, there is only one response. So if I go to, I don't know, Chipotle and ask for something to eat, it's only the person's only going to give me one response. They're not going to give me multiple responses at a time. I can only handle one response. So for each single request, there's always a single response. So you can't have one request make multiple responses back. And that you might think that's capable, but it's not. So for each response, there's always for each single request, there's always a single response. However, a single get, I would say if I visit a web page, it can kick off a bunch of requests at the same time. So like when I go to this Amazon, just do Amazon.com, it will actually kick off a bunch of requests. Let's actually clear the terminal. All right, is it done? Nope. Still making requests. I'll just open up a new one. So if I just go to let's do example.com, maybe that will give me multiple requests, but probably not. So if I go to example.com, it only gives me one response back. Get request, like so. That's what one request equals one response. But again, just because I visit a website or an application doesn't mean I'm able to kick off multiple requests at the same time. So if I go to target.com, I'm just going to clear that. This will kick off multiple requests at the same time. So when I visit their code in the server, it's going to kick off multiple requests and responses. So you can see here, I do a get request. Let's see there. I do a get request there. So there's multiple requests occurring. And a lot of it's all right, go to target.com, send me back the user, send me back all these images, send me back, I don't know, deals, send me back video, send me back the JavaScript. You can see everything, that's all the different requests that were kicked off by just visiting one website. So there's all this is being sent back. So you can even see like what is actually being sent. Like JavaScript, a lot of this is JavaScript, like for targeting items. So image, like images, all that stuff. But just know each request has one response. Any questions on that? So again, loading the HTML, one request, one response, loading the CSS, one request, one response, loading the JavaScript, one request, one response, loading images, one request, one response, etc. That's just for a single page, as you saw, just visiting target.com. So a lot of information, a lot of requests are being sent to the server just by visiting a single web page. All right. So HTTP is stateless, meaning that it does not know anything about any previous or future interactions between that server. So every time you visit target.com, a new HTTP connection is created, my data is sent to the server responds back, and then the HTTP connection is killed. And it knows nothing about any past or future interactions between that server. So it's stateless. It has no idea. It just doesn't remember anything before or after the response and request cycle. So every HTTP conversation begins with a new connection from the client to the server. It's as if those two parties are meeting for the first time. Even requests made just moments before have no bearing on the current request. So server state, most servers clear all state variables with each request. That means all state when processing a request comes from the request itself. So any data or information that the server utilizes to make the response comes from the actual request. But not everything is as it seems. So if each request is stateless, then how does like Facebook or Instagram know when I visit the page that I'm already logged in? Like, how does it know, like, how does it keep me logged in forever? It's because with cookies or local storage, you can send that data to the server through cookies or browser storage. So when you send a request, you can grab cookies, send those cookies to the server. The server will read the request, notice it has cookies, extract that cookie, process that cookie through the server, some code saying, hey, this person logged in, it should be already logged in. All right, log this person in. Great. So a lot of that stuff makes it seem like it's remembers, but it actually doesn't, because when you're actually making those requests, it's actually sending additional data to the server in the request from the browser through cookies or local storage or browser storage or session storage. So that's how websites know if I visit like facebook.com, it's already logged in, even though I destroyed that session or didn't closed out the browser. It's because there's cookies that tell Facebook, hey, I'm already logged in. So keep this person logged in for however 6 months or whatever it is. Questions on cookies or local storage or how websites or applications remember things about you? All right. Cooking in short, you'll learn more about HTTP cookies work, but for now, here's a summary. The server sets cookies by sending them to the client as part of the HTTP response. The client stores the cookies in the browser. The server does not store any cookies on their own side. Any cookies for the current domain are sent to the server as part of the HTTP request. So I kind of just talked about that. All right. So quick summary, HTTP is a proven protocol. It's extensible and has found uses far beyond what was imagined in 1991. Think, Netflix, YouTube, you're able to stream video, pretty crazy stuff. HTTP first changed the world by connecting users and servers to form the web. But today it's the foundation of so much more than the web. You'll soon realize HTTP is everywhere. And that is the end of that presentation. So we can quickly spin up a HTTP server on our local machine. Where is it? And kind of I think we did it initially by doing curl to go to a different, like if I went to curl www.example.com, you can see what is sent back in the body of the request. But let's actually go ahead and set up a HTTP server on our local machine. So I'm gonna you can set up an HTTP server on your local machine with relatively easy using Python by python-make http.server and what port you want the server to be running on. I'm going to do 8080. So if I click that, so I'm serving HTTP on server or on port 8080. That means that it's going to be on my local host 8080. So I've got a server running, an HTTP server running, and it's listening right now. It's listening to any requests coming in. And if I were to open up a new terminal, so it's listening. And if I were to do curl, I'll do v localhost. Is it localhost? Shoot. I think it's localhost 8080. Is that right? Do I need two? See
just one.
Is it just one?
HTTP. Oh, didn't you have to do HTTP? So you.
Let's see.
Protocol.
No. So.
Oh.
No. So I'm not actually sending anything in the request. So here you can kind of see I'm just doing curl. So it's connected to the localhost port 8080. So there is my request. So there's my request line. I'm doing a get request to / whatever, HTTP 1.1. The host is my local host. Let's see. Yeah. Localhost, my user agent. I'm using curl to do it, and I'm accepting any data back. So HTTP, this is what's being sent back, 1.0, assume close after body. So it's a 200 request, yay. Content length is 0 because I'm not actually sending anything back. But let's list everything out. So I've got this index.html, code index.html. And say I just want to say hello world, like so. I'm going to clear that. And now, instead of requesting localhost 8080, I want to localhost 8080/index.html. So so the reason why I'm currently located in this HTTP server directory, and that's where my server is running in this directory. So I'm going to request the index.html file in this directory. So now you can see what's being sent. I'm requesting index.html. It's the URI, HTTP protocol, localhost, curl, accept. Now I'm responding with these headers. So that's the response line, the headers, and then the body right there. And then it closed the connection. So you can see the GET request that came in. That first one came in there, and that's the second request that came in. All right. Any questions on kind of, you can see how an HTTP server kind of works. And again, this is all in plain text, this GET request, this stuff. So I can, if I wanted to, I can in theory create my own requests and responses using Python, creating strings, using a GET request, and creating this in code as a request. All right.